Hi everyone, my name is Fransiskus Agapa. I'm from Seattle Pacific. I go to Seattle Pacific University. I'm an intern at CMU. This summer, I'm part of data workflow team and Pittsburgh Supercomputing Center. Okay, the end goal of the project is automated generation of a big data bag submission for common fund data ecosystem from public primary data sets. Okay, before I talk about the project, I'd like to give a brief explanation where my team is in HuBMAP. Okay, HuBMAP has several components, and one of the components is HuBMAP integration visualization engagement, or usually we call it Hive. And Hive itself has several components, and one of them is infrastructure and engagement component, or IC. And one of the component of IC is data management, and this is where data involved some workflow team is located. And what we do is we do data injection and metadata submission. Okay, the goal of the project is automate the extraction, preparation, and submission of data and metadata requirements for common funded ecosystem, safety, and database of genotypes and phenotypes, and extract and prepare metadata for all public primary data sets. Okay, this data set contains of files where its files has contains data of samples of tissue from these specified organs, as you can see in figure A, and in figure B, this is how the data sets are being formed. Okay, next thing is the different. So there are three types of data sets. Primary data sets, it is raw data, derived data sets, and left derived data sets. Okay, the focus of the project is for my project is primary data sets. So I've been working only with primary data sets. Okay, this is the current HuBMAP architecture. This is maintained by Hive. As I mentioned earlier, I'm part of Pittsburgh Supercomputing Center, and our PSC maintain the blue boxes. They are shown here. And this is the current process of how data sets are being processed. Usually, the system needs people to detect new public primary data sets and validate it, compute it, and store it to the database. But one of the goals that we want to achieve is we want to make the process runs automatically, or another way of saying we want to take out human involvement. And this is the proposed HuBMAP architecture. So I put a little star in ingest analysis boxes. This is where my project is focused on. So in order for me to finish the project, we have two milestones to finish. The first milestones, we want to automate the process of computing file statistic. So here's the plan. We design clone package in Python, compute the file statistic, and store it to the database, and implement a workflow in common workflow. Okay, here's how it looks like. And so we take the data, we analyze it, we validate it, compute the files, and store it in the database. Okay, the second milestone is the goal is to automate the process and preparation of metadata submissions. The plan is similar to the first one, but the difference is the first milestone happens daily, and the second milestone happens quarterly or 4 times in a year. And we use Airflow for automating and scheduling tasks in workflow. Okay, here's how it looks like. Oh yeah, I forgot to mention that its files will be given a unique ID when we finish with compute the statistic. and this ID will be gathered into one as a metadata, which later will be submitted to Common Fund Data Ecosystem, or CFD. Okay, this big data bag is a format that we use to send the metadata. So all the data sets that we have computed will be put into the big data bag, and we'll send it to CFD search portal. Okay, the data summary. This is just contributing sites across the states and the different data set by essay type. Okay, here the summary. This is the new data sets that were saved for a project. So we received about 537 data sets, and they were 4.9 million files. Okay, this is the proposed milestone design for the first milestones, the system. So the idea is to, as I mentioned before, we want it to run automatically. So the system would detect new public primary data sets, and when it detects one, it will validate and compute it and store it to the database by itself. Again, the second milestones is slightly different. When the time comes to do the metadata submission, the system would validate and compute the statistic of public primary data sets, and other than store it to the database, it would create a big data bag and send it to CFD. Okay, these are the results. We were able to cover all of the data sets and the files in the data sets. However, when we try to retrieve the data sets from the database using UID API, we weren't able to retrieve all of them because it took a long time and the process stopped like right in the middle. So we were only able, these are the retrieval rate that we're able to. Okay, that's it. Okay, I mentioned before about metadata submission. So this is where the submission will be sent. We'll send it to this portal. So later people can access it, especially researchers and scientists to do further study. Okay, the takeaway, something that I learned and challenges that I noticed is the larger data set, then the larger data set that we receive, there is a high probability that not all the data sets can be retrieved, and the process and the response can be slower. That's why the system needs to be optimized to make it work more efficient and faster. Okay, this is the finalized poster. Yeah, things that I've learned. I mean, I've learned like using Jupyter Notebook, Spider, scientific computation with Python, and many more. And yeah, thank you. Special thank you to NIH, HuBMAP, CMU, and Pittsburgh Supercomputing Center for letting me do the internship, and also for my PI, Phil Blood, and my mentor, Ivan, for the assistance during the internship. Thank you so much.